Question number 8. Given that the first one, second, third, and fourth, with their delta H value given, calculate the standard enthalpy change of formations of H2O gas. Now, the first point you must be able to is to write down the equation for this term. What is the meaning of standard enthalpy change of formation of H2O gas? Is the enthalpy change when 1 mole of H2O is formed from its element. Its elements are H2 and O2. Bear in mind, you need to keep this as 1, so we need half O2. In other words, for part A, we need to solve this delta H. Do you understand? How? Look at the second equation. It's easy. This is the second equation. Very similar to our target. The only difference is this is gas state and this is liquid, with delta H equal to -28518. And then I copy down this equation. I haven't reversed and multiplied by a factor, so it is still equal to 44. In summing up these two equations, we can cancel out. There is one H2O liquid, there is one H2O liquid. Therefore, it is our target equation. And the delta H is kilojoule per mole. Can you follow? That's the answer. Next, B. You need to calculate the standard enthalpy change of formations of aluminum oxide. First of all, you are required to write down the equation for the term formation. Is the enthalpy change when 1 mole of aluminum oxide is formed from its element. Its elements are aluminum and O2. According to the definition, we need to keep this as 1. So we need 2 and we need 3/2. Understand? Now look at the last equation. Its delta H is given. Compare this and that. Simply, we can divide this equation by 2, then you can work out the answer, which is do you understand? Next, C. Calculate the standard enthalpy change of formation of this one. Again, write down the equation. This is the most important. Formations of ammonium nitrate is the enthalpy change when 1 mole of ammonium nitrate is formed from its elements. Its elements are N2, H2, and O2. This is your target. Balance this equation, keep according to the definition, keep this as 1. Then we need 1 N2, we need 2 H2, and we need 3/2 O2. Do you understand? Now compare this with which one? Okay, now this is our target. This is the target equation. So, how to solve the problem? Now, first of all, we need N2 on the reactant side. Look at the first one. We have N2, but it is on the product side. So obviously, we need to reverse the first equation and multiply the, maybe I reverse first. In doing this, the delta H changed from negative to positive. Next, we need to multiply the equation by 2 and divide by 3. Multiply the equation by 2. Now, I do it step by step, okay? Multiply the whole equation by 2. For the delta H, it must be multiplied by the same factor. And then next, divide the whole equation by 3. So, divide the value by 3. Do you understand? Oh. Next, we need to cancel aluminum by using another equation. This is the equation with aluminum on the reactant side. But we need to divide the whole equation by 2. Divide the whole equation by 2, followed by 3. Divide the whole equation by 3. Can you follow? So, if I do summation on these two equations, I can cancel out this term and cancel out this term. And also this term and this term. Do you understand? Finally, we need to cancel H2O gas. H2O gas by using this equation. H2O gas. So I copy down this equation first. In copying this equation, the delta H is still equal to 44. And then multiply this equation by 2. Okay? Multiply by 2. Then in doing summation, I can cancel H2O gas. Finally, we need to cancel out H2O liquid. H2O liquid. So I copy down the second equation first, and then multiply the equation by 2. Copy down, multiply by 2. Understand? Now I can cancel these out. Finally, what's left behind? Let's check. On the reactant side, we have N2. Cancel out, cancel out, cancel out, cancel out. O2 and half O2. We have 3 over 2 O2. And then we have 2 H2. Now what's left behind on the product side? Only NH4, NH3, which is our target reaction. Therefore, the delta H is equal to the summation of these terms. Kilojoule per mole. It's difficult, so please try by yourself.